In this video, we are going to see the first order systems. Okay. In the last video, we have already seen what is a pole and what is zeros. Poles are the roots of your denominator equation in a transfer function, and the zeros are the roots of your numerator. So first order systems are going to be systems which have only one pole. So the standard block diagram of the first order system will have a transfer function of 1 by Ts in the forward loop, and the feedback loop is having a gain of 1. So if we consider a negative feedback system, your transfer function is going to be 1 by 1 plus st. Okay, and the t here stands for your system time constant, and the system time constant, it characterizes the speed of response of a system to an input. So higher the time constant, your response is going to be slower, and if the time constant is of a low value, your response is going to be faster. Now we are going to see the response of a first order system when the system is subjected to a unit step input. So as I said, the closed loop transfer function C of s by R of s is given by 1 plus st. Now if the input is unit step, your R of t is going to be 1, and so your R of s will be 1 by s. So the response in s domain is going to be C of s is equal to R of s into 1 by 1 plus st. So if I multiply my R of s along with it, it is going to be 1 by s into 1 by 1 plus st. This can be rearranged and written as 1 by t by s into s plus 1 by t. Now you have already learned in your lower engineering semesters the partial fraction expansion. So we are going to solve this to find the C of t, the inverse Laplace transform. We need to apply the partial fraction method. So the 1 by t by s into s plus 1 by t is written as a by s plus b by s plus 1 by t. And as you already know, to obtain a, you need to multiply the C of s by s, and then you need to let your s is equal to 0. So your a is found out as 1, and the b is obtained again by multiplying C of s by its denominator, that is s plus 1 by t, and you need to substitute s is equal to minus 1 by t. So you're getting b having a value of minus 1. So your final expression will be C of s is equal to 1 by s minus 1 by s plus 1 by t. So to get the response in time domain, you need to take the inverse Laplace transform. The inverse of 1 by s is 1, and the inverse Laplace of 1 by s plus 1 by t is e raised to minus 1 by t. So the final, for a closed loop response system, the final unit step response is going to be 1 minus e raised to minus 1 by t. And if you have instead of unit step, if it is just a step response of some magnitude a, your response is going to be a into 1 minus e raised to minus 1 by t. So let's plot and see how the output is going to look for a unit step input. So if I have a unit step input, I'm going to substitute my small t ranging from 0 to infinity, and we have found out the various values of c of t, and we can see how the curve is going to be. This represents your response for a unit step input. So this is for a first order system.